Okay, in this video we'll be talking about the Pythagorean theorem, the distance formula, and the midpoint formula. So the first result we're going to talk about is the Pythagorean theorem. Most of you probably already know it, so this memorization alert here is not a very big deal, but it's still worth refreshing. So Pythagorean theorem only works in a right triangle, that is, a triangle that has a right angle in it. So if you consider the hypotenuse, which is the side opposite the right angle, and if it has length C, and you have the two other sides, which are the legs, have lengths A and B, then it must be that when you add up the squares of A and of B, then you always get the squared of C, okay? Now, an interesting thing about the Pythagorean theorem is it actually works the other way. Namely, if you have a triangle, if you know that A, B, and C are sides of a triangle such that they follow the Pythagorean theorem relationship, then you automatically can conclude that that triangle has to be a right triangle. One sort of justification for this is 3, 4, and 5 for side lengths of a triangle will always form a right triangle, since 3 squared plus 4 squared equals 5 squared. This is called a Pythagorean triple, that series of numbers. Another good one is 5, 12, and 13. Always work that as well. That way as well. So you can see sort of the relationship here, and if you really want a challenge, try drawing it for 5, 12, and 13. These two sides will be really big. But this sort of shows you the relationship. Namely, if we add up this number, these boxes, into those boxes, you'll get those number of boxes. So it's just an interesting sort of visual to consider. Now, the most important thing about the Pythagorean theorem for our purposes is that it can be used to derive the distance formula. Namely, we want to know how do we calculate the distance between two different points in the xy plane. Well, the way we're going to do this is we notice here that we can draw a right triangle of the make this out of that, where the side length that we really want to find in this right triangle is our hypotenuse, because that's a right angle. Now, we can find the hypotenuse question mark squared, so to speak. Let's call it D. We can find D by noting that the distance D is equal to A squared plus B squared, because this is a right triangle, and so the Pythagorean theorem applies. So D squared equals A squared plus B squared. However, we notice that A is the distance between y2 and y1. Namely, we see here that A is equal to the distance between y2 and y1. Okay? And this is always the case. It doesn't matter where y2 and y1 were. Same with x1 and x2. It's always going to be those distances. So A is y2 is the distance between those two. X is the distance between those two. Remember, this is how you represent distances, as the absolute value of the subtraction of the two numbers. Okay? So in other words, this right here is A, and this distance is B. So B is x2 minus x1. So, in other words, what we have here is, we actually have that D squared equals x squared equals the absolute value of x2 minus x1 squared plus y2 minus y1 in absolute value squared. Of course, because these are squares, we know that the answer will be positive, so we can drop the absolute values. Minus x1 squared plus y2 minus y1 squared. Of course, if that's the case, now we can go ahead and take our own square root. Now, when we take our own square root, we always have to put in a plus or minus. Of course, here, we know that we don't really need the positive, so we don't need the negative, we can get rid of it. And the reason we can get rid of the negative is because it doesn't make sense to have a negative distance. We would have to have a positive distance. So, this then, as I said, gives the distance formula. That is, the distance between the points x1, y1, and x2, y2 in the coordinate plane is always the dis is always d, which is the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. Namely, what if we wanted to find the distance between the point negative 2, 1 and 3, 4? Well, we could graph this, but there's really no point to. Namely, what if we can just go ahead and use the formula, right? So this would be the square root of, let's say this is going to be our second point, so x2 would be 3 minus x1, which is negative 2, the first coordinate in the first point. Because the first coordinates are always x-coordinates, the second coordinates are always y-coordinates. Plus the difference, but the difference in the y-coordinates. y2 would be 4, y1 would be negative 2, would be 1, sorry. So minus 1. So here you got to be a little bit careful to make sure you preserve any negatives in the coordinates, because we know that subtracting a negative is adding, namely 3 minus negative 2 is really 3 plus 2 squared plus 4 minus 1 squared. If we do that out, we get 5 here plus a 3, so 5 squared plus 3 squared. 5 squared is 25. 3 squared is 9. So we have the square root of 34. 34 can't be reduced because its only factors are 2 and 17, and we only have one of each of those factors, so we can't pull any out. In other words, what are we saying here? What we're saying is, if we were to actually graph these, namely, so if we go down negative 2, 1, that point would be there. And if we go up to the point 3, 4, so 1, 2, 3, 1, 2, 3, 4, we would have that if we were to graph the if we were to actually measure the the length of this line segment, what we would have is that distance would be the square root of 34 in terms of where 1 is counted as this length of this, of any of these difference between the tick marks. So another application of using the distance formula is that we can actually show when 3 points create a right triangle in the plane. Namely, you could try graphing these like so. So this is the triangle that would form from this. It looks as if that is a right angle. But how would we check it? Okay, we don't necessarily know that it is. Well, the way we would check it is we would need to check all these distances in the Pythagorean theorem. That is, if A is that distance, B is that distance, and C is that distance, does it follow that A squared plus B squared equals C squared? Well, let's check those distances. So for A is the distance between A and B. So A equals the square root of 4 minus 2 squared plus, plus 0 minus 1 squared. What does that give me out? That gives me out square root of 4 minus 2 is 2, squared is 4. 0 minus 1 is negative 1, squared is 1, so that gives me the square root of 5. B, the different distance B here would be A minus C. So would be the distance between A and C, the points A and C, right? So we'd have 5 minus 2 squared plus 7 minus 1 squared. And then look at the square root. That being, and then simplifying that down, 5 minus 2 is 3, squared is 9, plus 7 minus 1 is 6, squared is 36. 36 plus 9 is 45, so we'll just write square root of 45. And now for C, what we notice is, for C, we have, C is the distance between B and C, so we have 5 minus 4 squared plus 7 minus 0 squared. That is, we have 5 minus 4, which is 1, squared is 1 plus 7 squared is 49. If we do that out, then we get 50, the square root of 50. And what we notice is now that if I do a squared plus b squared, does that equal c squared? Well, if we plug in, we get square root of 5 plus the square root of 5 squared plus the square root of 45 squared. And we want to know, is that equal to the square root of 50 squared? And it is, because we have 5 plus 45, and here if we unsquare, we get 50. So it does actually work. So that is a right triangle. There is a simpler formula that we can consider, namely to find the midpoint of the line segment that joins 2 points, x1 and y1, x1, y1, and x2, y2. We can find the average of the two coordinates, x1, x2, and the two coordinates y1 and y2 separately, like this. So remember, to calculate the average of any two numbers, you add them together and then divide by 2, and that always finds the number directly between the two, perfectly between the two. Well, if we do that in each of the coordinates, then that should give us the midpoint of the line segment itself. This is easily seen of why this is true. If this were x1, y1, and this were x2, y2, then how do we figure out the midpoint of this line? Well, the way we do it is we look at the line between x1 and x2, which is this line, and we find its midpoint. The midpoint between y1 and y2, we find the average of those two. Oh, sorry, that would be that point. This would be the one between x1 and x2. But it doesn't matter. You do this in each of the coordinates, and that will give you the midpoint, always. So be sure to memorize this. For example, if we wanted to find the midpoint of the line segment joining the points -5, -3, and 9, 3, we could just go ahead and calculate the average of 9 and -5. And we could also calculate the average of -3 and 3. 3 over 2. This 9 plus -5 is 9 minus 5, which is 4 over 2. And here we have -3 plus 3, which is 0 over 2. Well, 4 divided by 2 is 2. 0 divided by anything is 0. So there we have it. And now it's time for you to try an example. So go ahead and find the midpoint of the line segment joining the points -2, 8 and 4, -10. On the count of 3, I'll reveal the solution. 1, 2, 3. And there's the solution. For more practice in playing around with the Pythagorean theorem, the distance formula, and the midpoint formula, be sure to see pages 8 and 9 of the textbook and work problems numbers 17 through 36. In our next video, we'll talk about graphing equations.